Here we're going to learn about Hamilton's method, which is the method of apportionment. So let's recall what we had done. Our first steps in apportionment were as follows. We divided the entire apportionment population of the United States, which was about 309 million, by the number of seats specified in the House of Representatives. That's 435. And when you do that, you obtain a number, 710,000 and so on. That number is called the standard divisor. You see, no matter what you do, that's going to be the average number of people represented by one seat in the House of Representatives. That's the average size of a district in the House of Representatives. Now, to find out how many representatives or how many districts each state should have, what you would seem to need to do is to divide its population by this number, the standard divisor. So for example, for Ohio, we would divide its population of 11.5 million and a bit more by the standard divisor, 710,000 and so on. When you do that, you get a number 16.276. That is called the standard quota, or simply the quota for Ohio. And what should you think? You should think, oh, well, this is the number of representatives that we deserve, 16.276. Of course, we can't have 16.276 representatives. For that reason, we find it useful to introduce the following vocabulary. If you just take the integer part, in other words, you round this number down, you will get the number 16. That's called the lower quota. If you round it up, that would be in Ohio's case to round it up to 17. You will get something called the upper quota. And if you take the quota and just take the part that's after the decimal point, we're going to call that the fractional part. Okay? So for Ohio, there it's illustrated. Lower quota 16, upper quota 17. Fractional part is 0.276. Now, a quota method is any apportionment method that's guaranteed to give each state either its lower quota or its upper quota. Here we are going to learn about one of those methods, and that's Hamilton's method. All right, so what does Hamilton say to do? He says, first of all, give each state its lower quota. Except, remember, of course, every state is supposed to have at least one representative. So in some cases, the lower quota will be 0, and that means, of course, that state should get its automatic one seat, and that's all it will ever get. Now, if you do what Hamilton says to do, you give out its lower quota, you can't be finished. You see, what has happened almost certainly is that you haven't given out all the seats. You've given out a lot of them, but not all of them. For example, in the House of Representatives, which is the example that we continue to do, there's 435 seats, and if you give each state its lower quota or its automatic one seat, you should expect to have maybe about 25 seats left over. There will be leftover seats. So now we need a second stage in the apportionment. After giving each state its lower quota or automatic one seat, what do you do next? Well, there are these leftover seats, maybe about 25 of them, and what Hamilton says to do is give the leftovers to the states with the largest fractional parts. That's it. You just look at fractional parts. Whichever among the states have the largest ones, they get those leftovers. Now, of course, this should not apply to those who just got the automatic seat, right? If you're that small, you don't deserve a second seat. So we're just going to leave those out of the competition for the leftovers. Let's do an example. Now, I'm not doing the U.S. House of Representatives here. I'm just doing a silly made-up example. If you are a fan of Star Wars, you'll recognize these as names of planets in the Star Wars stories. And let's suppose that those are the populations as I've given them over there. I just made these up completely, of course. And let's also suppose that the number of seats in the House of Representatives, or whatever it is, the Galactic Senate, or whatever it may be, is 100. There are 100 seats. All right, so what we have to do is we have to take the total population. We get that very simply by adding up the populations of the planets. And then we, of course, want to divide by 100, which is a very easy thing to do. We move the decimal point. We get the standard divisor of 960,981.38. Next step. Well, we now divide each of the populations of the planets by the standard divisor. Okay, so think we're taking each one of those populations up above, all 8 of them, I believe it is, and we're dividing by this standard divisor, 960,981. And when we do that, we come up with the standard quotas that are listed there. Right? There's a column that says standard quotas. Sure enough, if you add up the standard quotas, you get 100. Of course, you have to, just by the way that you've done it. Now, we can take each of those and round them down and round them up, and we get the lower quotas and the upper quotas. So, for example, for Endor, the standard quota was 12.027. If you round down, you get 12. If you round up, you get 13. Now, what Hamilton says is that everybody should get their lower quota. So we're going to hand out to each planet its lower quota with one exception. The exception is Dagobah, because Dagobah's lower quota is 0. So Dagobah doesn't get 0, it gets 1. So in this first step, we're going to hand out a certain number of seats. It's not 96, as a matter of fact, it's 97, because of that automatic 1 that we gave to Dagobah. Now, what that means is we haven't completely filled up the seats. We've filled up 97, and that means that there are 3 left over. Well, what do we do with those? We look at the fractional parts. Okay, so let me give you an additional column here showing the fractional parts. Notice that Dagobah is not in the competition, so it's just pointless to list its fractional part. It already has its automatic 1 seat, and that's all it's going to get. So I've listed the 7 fractional parts over on the right, and now we need to look and decide which of those 3 are the 3 largest. Sorry, which of those 7 are the 3 largest. Okay, we pick out the 3 largest. The largest, as you can see, is the planet whose name begins with a G. I won't even attempt to pronounce it. And then there are 2 others. In fact, here they are shown in red. Okay, so those are the 3 largest fractional parts. Those 3 planets get their extra seat, therefore they get their upper quota rather than their lower quota. And there's the Hamilton apportionment, showing you the number of seats given out to each planet, and of course it adds up as it's supposed to 100 seats.